If I tell you that I trained a CNN model with more than 21,000 handwritten digit numbers, getting a final performance of 98.6% of accuracy, with a minimalist frontend and packaging the entire app in a Docker container in less than 3 hours, will you believe me? Okay, let me show you how. The first step and the key factor that determines how much time you invest in your project is planning. Good planning is almost the only thing that we need to succeed. So this is what I planned. I want to make sure here that there are many ways to create a good plan, but in my case it was a small project, so I decided to define questions. What do I want to build? A CNN model that predicts handwritten digits through a UI interface. With what will I build it? Here I have a slight issue. I didn't have the necessary skills to develop the frontend for my project, but nowadays there is a solution for that. We will see it later in the video. How will I build it? I define all the steps: train the model, test the model, migrate to a better IDE, create fast API architecture, create frontend, and package in Docker. What are the risks and obstacles? Like I already say, in this case was my limited knowledge of frontend. I just skipped some planning questions that were necessary for my project, and with that, we have a plan. The next step is to follow the plan. Train the model. I went to my Google Colabs, export the entire dataset, and explore it. The images had a white background with blue ink. Under those conditions, the model wouldn't achieve high accuracy because of the high contrast between the white and the blue. So I transformed the images into a black background with white ink. Then I resized them and normalized them. The normalization is important because it puts all pixel values into the same 0-1 range. Now with the data prepared, I split into training and test data. Using TensorFlow, I built the model, fed into the training data, and executed. This video is not focused on how to build the CNN model itself. It's more about the end-to-end deployment process. But if you're interested in the model architecture, I will leave the link to my GitHub repository. Once the model was built, I evaluated it, and after some adjustment to the model layers, I reached a maximum accuracy of 98.63%. An excellent number for a first shot. Why? Because we work on a preprocessing pipeline to fit the model with data in the best condition possible. Now it's time for the deployment. For the API calls, I used FastAPI because it is fast. But before setting it up, I moved my CNN model from Jupyter Notebook to my project directory. I could have simply copied the model file, but I also want to include the preprocessing and architecture inside the project. For the FastAPI, I start by creating the input model and response model, then a path to load the model. I created a single endpoint that received the user's number request and sent back the model prediction. And that's it. We don't need more than that for our handwritten digit prediction app. Do you remember that I said that I didn't have experience in frontend? Well, I have two options here. Invest more time in learning how to create a simple frontend for my app, or use AI. Because the objective of my app wasn't learning frontend, I prefer not to invest time in a simple frontend that is easy to create with our latest AI models. I used Cloud Code with a really simple prompt, and in just a snap, Cloud finished my whole frontend. I tested and it was working perfectly. The last step was to pack everything into a Docker container, and voila! A machine learning application in less than 3 hours. Sometimes, these complicated terms make us think that building, training, and deploying models is much harder than it actually is. I know, my project was a small project, but the truth is that with a clear goal and plan, anything is possible. Thanks for watching and see you in the next time.